To solve a problem involving circle graphs and thinking about how the part to whole and part to part comparisons are related, and we're going to use those to find the answer to our problem. So let's take a look. A survey of 150 employees at a company asked which type of transportation the employee uses to get to work. The types of transportation and some of their percentages are shown on the circle graph. Types of transportation, and we can see that we have car 38%, bus 20%, train 32%, and bicycle. How many more people use a car than ride a bicycle to get to work? The first thing I need to figure out is what is it I'm being asked to find? So looking back at our question, how many more people use a car than ride a bicycle to get to work? How many more reminds me of finding a difference or subtracting something. But I don't know the number of people or the number of bike riders, because basically on my graph here, my circle graph, I've been given percentages. So it looks like I'm going to have to find out some of the parts to be able to answer this question to find the difference. So I need to find how many more people use a car over a bicycle. Let's use what we know in the problem to kind of pull together some information. I need to find the number of people for each of the percentages. So I have to find the parts of bicycle riders and those that use a car to get to work. Car has been given to me as it's 38%, but bicycle is unknown. I don't know what that percentage is at this moment. They also told me that there were 150 people or employees that were surveyed. And we already talked about we're going to have to find a difference to figure out how many more people use a car than ride a bike. So before we start trying to figure out the number of people that are using a car or riding a bike, we have to figure out what this percentage is for bicycle. So to do that, we can take the existing percentages, 38, 20, and 32, add them up, and then you guessed it, we're going to subtract from 100, because remember, percents are always out of 100, so this whole graph represents 100%. So 100 minus 90 is 10, so that means our bicycle riders make up 10% of those surveyed. Now I can use this information, the 10% and the 38%, to find out how many people that actually represents. So we're going to need to set up some proportions. So if I set up a proportion to find this, 10% of that 150, or 38% of 150. So when working with proportions, I want to see if I can figure out how I get from 150 to 100 or 100 to 150. I didn't see anything, so I can reduce this fraction to 1/10. Now I'm thinking I can multiply something by 10 to get to 150, or multiply by a fraction to get to 10. What could I use to do that? So to me, I can see that this is like multiplying by 1 over 10 to get to 10. Or if you think about going this direction, instead of doing that dividing by 15, I could multiply by 15. So 1 times 15 is 15. So there's 15 people that rode that bicycle. Then we have our car folks at 38% out of 150. Remember, percent is out of 100, and we're doing this out of 150. So again, I want to look to see, I don't see that right away. So what could I do? I could look to see if I could reduce this fraction. So when I reduce this, I could divide both 38 and 100 by 2 and get 19 over 50, which then makes me think, okay, how do I get from 50 to 150 or 150 to 50? I need to go backwards. So to me, I remember that 50, 50, 50 is going to give me 150. So 50 times 3 will give me the 150. So that means I would be multiplying 19 times 3, which is going to give me 57. You can use your calculator to do that, or just 3 times 9, 27, 3 times 10, 30, so 30 and 27 is 57. So now that we know our values here, I somehow erased that, sorry. 15 bicyclists, 57 drivers that are driving their cars to work. I notice my 15 and my 57 are also numbers that are in our answer choices. So don't be fooled and stop too early, because we've only found the number of people riding their bike to work and the number of people driving their cars to work. What we were asked to do was to find out how many more people use a car than ride a bike to get to work. Neither one of those numbers is going to actually give us the answer. So it's either going to be 28 or 42. So let's find out. So remember, we talked about car, the number of people riding the car or driving the cars minus the bicycles. So we're going to take 57 people minus the 15 bicycle riders, and we arrive at the answer of 42. The difference between the people using a car versus that of a bicycle is 42. So our correct answer choice is C, 42.